Okay, so in this video, I'm going to be doing operations with matrices. So basically, matrix math kind of works like regular addition and subtraction. When we get to multiplication, things are a little different. If I'm doing scalar multiplication, that's just multiplying by a constant, then it'll be normal. It's when I multiply two matrices together that the math is a little different. These ideas are kind of building into abstract algebra, where different number systems work in different ways for maths. The math can be different if I define my groups differently, which a matrix is a group and it's defined differently. But we're just going to focus on adding, subtracting, and scalar multiplication today. Tomorrow we'll do matrix multiplication, so multiplying two matrices together. On number 1, it wants me to solve for A11, A12, A21, and A22. These, remember, like I said in the first day of 8.4, are just the positions of these. So A11 is my first row, first column. That is 2. A12 is my first row, second column. That's -1. A21 is second row, first column. That is -3. And A22 is second row, second column, which gives me 0. That's all I have to do in this one, is I just have to recognize which positions each of those go in. So pause the video, take a minute or two to work on number 2, and then when you think you've got it, hit play so you can check your answer. So same thing like before. A11 is my first row, first column. That's 6. A12 is first row, second column. That's 3. A21 is second row, first column. That gives me -2. A22 equals 4, because that's second row, second column. So next thing we're going to talk about is adding and subtracting matrices. We can only do this when they have the same dimensions, so same rows, same number of rows, same number of columns. Otherwise, I can't do that. And then I just add the positions together. So I add the first row, first column together, the second row, second column together, first row, second column together, and so on. So this one, I have a 2 by 2 and a 2 by 2. So I can go ahead and add these together. So my first position is a -1, and I'm going to add that 1 from the first position of my second one. Then for the next spot, I have 2, and 3 is the matching one in the next spot. Over here, I have 0 and -1, and then 1 and 2. So then I just actually want to go ahead and simplify. -1 plus 1 is 0. 2 plus 3 is 5. 0 minus 1 is -1. And 1 plus 2 gives me 3. This is my final matrix. All I had to do was add. So if I had had a subtraction sign in the middle, I would have just subtracted the two numbers. Over here on number 4, I have a 2 by 3 and a 2 by 2. Notice I do not have the same dimension. This one is a 3 and this one is a 2 for my number of columns. I can't add. So I'm going to say not the same dimension. You don't have to write this for every answer, but I would write this for your notes. So what I'm going to do here is write undefined, because I can't add them together. Same thing. Pause the video, take a few minutes to work on the next 2. When you think you've got your answers, come back and check. So number 5, I have a 2 by 2 and a 2 by 2. So I'm good so far. I can go ahead and add these together. I have 4 plus 2 for my first position, -1 plus -1 for my second position, 2 plus 0 for that bottom position, and -3 plus 6 for the bottom right. Then I just want to go ahead and combine. 4 plus 2 gets me 6. -1 plus -1 gets me -2. 2 plus 0 gets me 2. -3 plus 6 gets me 3. This is my final answer. On number 6, I have a 3x1 and a 3x1. So same size, I can go ahead and add these together. I have 1 minus 1, -3 plus 3, -2 plus 2. This one will give me all zeros, but that's okay. And that is my answer here. Okay. On the back, it wants me to do scalar multiplication. So what this is I take a constant number and multiply it with every term in the matrix. So number 7 wants me to find 3a and gives me this matrix A. All of those points are going to be multiplied by A. So that first 2 in the first row is going to be multiplied by 3. Did I say it was going to be multiplied by A? I meant 3. Over here, I have 2 times 3, 4 times 3. Next row, I have -3 times 3, 0 times 3, -1 times 3, 2 times 3, 1 times 3, and 2 times 3. I want to go ahead and just multiply each of those terms. So it's going to give me 6, 6, 12 for my first row, -9, 0, -3 for my next row, 6, 3, 6 for my final row. So when I have a number in front of a letter, it just means multiply each of my terms by that number. So again, I would like you guys to pause the video, take a few minutes to work on number 8, and when you think you've got the answer, come back and check. So again, on number 8, it is having us multiply by 3. So I'm going to take each of my terms and multiply by 3. I'm going to have 4 by 3, -1 times 3, 0 times 3, 4 times 3, -3 times 3, and 8 times 3. Then I just go ahead and multiply. I'm going to have 12, 0, -9. And I'm going to have -3, 12, 24. And this is my final answer here. So the final thing we're going to do is we can combine multiplication and addition and subtraction. This one wants me to find 3a minus b. So I'm going to multiply my first matrix by 3, and I'm going to subtract the second matrix away. Before I even get started, I just want to check to make sure these are the same size. A is a 3 by 3. B is a 3 by 3. So I will be able to subtract. Remember to add and subtract. They have to be the same size. So first thing I want to do is I want to find 3 times that A matrix. So I'm going to take all of those terms and multiply by 3. Oops, there should not be a plus sign there. That should be a 3. I don't know where I got that 0 from. And I'm just going to write a minus, and then I'm just going to copy my B matrix down for now. Okay, so I'm going to simplify my first matrix. That's going to give me 6, 6, 12, -9, 0, -3. Nope, not 2. 6. 3, 6. And I am still subtracting the B matrix away. So then what I want to do next is in each of my positions, I am going to subtract the matching position from the B matrix. So I have 6 minus 2 for that first row, first column, 6 minus 0 for the first row, second column, 12 minus 0 for the first row, final column. Then I have negative 9 minus 1, 0, minus from in between, and then it's going to be a negative 4 from on the matrix. Then I have 0 minus 3. Where did I get 0? That should be negative 3. My bad. Then I have 6 minus negative 1, 3 minus 3, and 2 minus 6. So I want to go ahead and solve each of those positions. That's going to give me 4, 6, 12, negative 10, positive 4, negative 6. Then I'm going to have 6 minus negative 1 is the same as adding. That's 7. 3 minus 3 is 0. And 2 minus 6 gives me 2 minus 6. Should be 6 minus 2. I wrote that backwards. Gives me 4. So this is my final answer here. Okay, so pause the video, take a few minutes to work on number 10, and when you feel ready, hit play to check your answers. So over here, I am going to eventually subtract my two matrices, so I want to make sure they're the same size. This is a 3 by 2, 3 by 2. They can go together. The first thing I want to do is multiply my first matrix by 3. So I'm going to have 4 times 3, and then negative 1 times 3 for the first row, 0 times 3, and 4 times 3 for the second row, negative 3 times 3 for the third row, and 8 times 3 there as well. I am going to be subtracting, so I'm going to write that subtraction sign. And then the second matrix is getting multiplied by 2, so I'll also do that at the same time. I have 0 times 2. That 0 looks weird. Let me fix it. Then I have 4 times 2, negative 1 times 2, 3 times 2, 1 times 2, and 7 times 2. So I want to go ahead and actually multiply out each of my positions here. First matrix, first row, I'm going to get 12, negative 3. Second row, I'm going to get 0, 12. Third row, I get negative 9 and 24. Second matrix, I am going to get 0, 8 for my first row, negative 2, 6 for my second row, 2, 14 for my final row. Then I want to go ahead and combine these together as one matrix with the subtraction in between each of my matching positions. So I have 12 minus 0, negative 3 minus 8 for my first row, 0 minus negative 2, because there's a minus here and a minus in front of that too. 12 minus 6, negative 9 minus 2, and 24 minus 14. I'm going to go ahead and actually combine each of those numbers in each position. 12 minus 0 is 12. Negative 3 minus 8 is negative 11. 0 minus negative 2 is 2. 12 minus 6 is 6. Negative 9 minus 2 is negative 11. And 24 minus 14 gives me 10. So this is my final matrix after the scalar operations and subtraction have been performed.